Welcome to Mechanical Y. Today we will be discussing conics. As the name suggests, conics is the study of cones. Here I have two cones that are equal to each other and they are connected at the vertex. Now imagine that these cones continue onward to infinity in both directions. So what do I do with these cones? Well, I take a cutting plane and I slice through these cones in different ways. And what happens is that this cutting plane creates a shape as it passes through the cone. The study of these shapes is conics. So what kind of shapes can I create by cutting through these cones in different ways? Well, let's start with one of the simplest shapes. Let's cut perfectly horizontally across the top cone. With this cut, it's pretty easy to see that the shape that is created is just a simple circle. Now, circles are found everywhere in life and it's a pretty common shape. But what happens when I start inclining the cutting plane at a different angle that's not perfectly horizontal? Well, I get a new shape, and this shape is the first fundamental shape of conics. The shape that I get looks something like this. And as you'll see, it looks like a slightly stretched out circle. This is a special kind of shape known as an ellipse. Now, the steeper I make this cutting angle, the more stretched out and oblong this shape becomes. The shallower I make this cut, the more it approaches a circle. And a circle is merely a special case of an ellipse where this cutting plane is perfectly horizontal. And depending on the angle that I cut it, the different type of ellipse I can make. But what happens when I reach a critical point? What happens if I make a cutting plane that slices through these cones at a very particular angle? This angle is exactly parallel to the side of these cones. I get the second fundamental shape of conics, and this shape is known as a parabola. As you notice, the cutting angle would enter one of the cones, but it could never exit the cone because it is exactly parallel to one of the sides, and it will never intersect it. Likewise, on the bottom cone, since the cutting plane is parallel to that too, it will never intersect the bottom cone either. So we get this shape that is closed on one end and would continue on to infinity at the other end. And a parabola only exists at this very critical angle where that cutting plane is exactly parallel to the side of the cones. But what happens when that angle is not exactly parallel to the side of the cones? Well, in one direction we would get an ellipse, but what if we make it steeper than that? Well, we get the third and final fundamental shape of conics. What you'll see happen is that just like a parabola, this plane would cut through the top cone, but then would stay inside of it for infinity. But because that cutting plane is not parallel to the side, it will eventually intersect the bottom cone as well and remain in that cone on to infinity. Now this makes a special shape that is known as a hyperbola. And as you'll see, this shape is symmetric both on the top and bottom parts of the cone. So why are these shapes important? Why do we study conics? Well, these shapes are found in everyday life. For instance, a parabola is used in a lot of reflecting applications. Things like reflecting dishes on headlights or satellite dishes tend to be parabolic shapes. Circles and ellipses are used very commonly in construction to create domed structures. And these shapes are even more important when it comes to astrodynamics, or the study of the way heavenly bodies orbit each other in space. For instance, the moon orbits the Earth in an elliptical orbit. If I were to send a satellite on a flyby trajectory next to another planet, that trajectory would be a hyperbola. And the interesting thing is cutting through these cones with this cutting plane doesn't create approximate shapes. These shapes are mathematically precise. They are in fact the definition of these shapes. And it's very important that simply cutting through these cones in different ways makes real shapes that are useful in real life in very many important ways. Well, I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on new content.